So, alright. So if you guys see me sweating, see my shiny face, don't worry about it because that is how I grew up. So I grew up in a place where there was no electricity when I was small. So I literally enjoy the sweat. Don't think that your teacher is getting stressed out. I'm just enjoying my childhood right now. Okay, so what are we going to cover today? If you guys remember in the last class, basically we have started the unit which is all about data, distribution, spread of data, center of data, and then analytics around that. So you would have heard about all these concepts in bits and pieces, and what we are doing as part of this unit is we are putting them all together. So that is where we started learning or revising what is mean median mode, what is its importance, and then how do we relate that with real life scenarios that we come across. And then we looked at standard deviation in the last class. I hope everybody remembers that, at least from a concept standpoint. We should not be wondering if somebody utters the word standard deviation and start grappling with, okay, what exactly it is. That should not be the case. As long as conceptually we are clear, at least my job is partly done. And why I'm saying partly done, because we'll come back to the same topic again after a few months. So is that a fair assumption that you guys are at least clear with respect to whatever we have learned with respect to mean, median mode, standard deviation part so far?
Yes.
Oh. Now, in this class, as I mentioned, we are going to talk about, we'll randomly pick one problem that we wanted to solve. And again, that will just give you a flavor of what kind of problem that you guys will come across when it comes to dealing with the things that we learned in the previous class. Just one of the question. And then we will move on to the data representation part. So far we have dealt with the data manipulation part. Then we'll, with the next step, which is data representation. That is where we will talk about different types of graphs or the tools that we use for data representation and what is the purpose of it and how do we interpret by looking at different tools. Likewise, we'll talk about scatter plots. And again, all these different bars, different charts and tools that we'll talk about, the idea is not to figure out how to draw them, because how to draw them is very easy. That you guys would have learned, and we'll again do a recap of that. But what I'm saying is, our focus has to be more on why those tools are there, what is the purpose that it solves, and how do we take some meaningful insight from those tools and or techniques that we are going to learn. Okay, so let me pick up one problem relating to the topics that we covered in the previous class, and then we'll jump on to the data representation part. So now comes my boring technique of read, analyze, and then do it. So I'm reading the question for you guys, okay? I have, the question has something plotted here, okay? You have month written here, and then second column you have civil aircraft produced. So you are essentially looking at two columns, a table with two columns, okay? Then you have A 400, B X, C 286, D 350, E 290. Okay, so what you are seeing right now on the table is, on the board is the table which has two columns. First column is month, second column is civil aircraft produced. First row is month A 400, month B X, month C 286, month D 350, and month E is 290. This is a table that is there as part of the question. Now I'm reading the next information that we have there. The table partially reports the number of civil aircraft produced in the United States during the course of 5 months. As we can see from the table, this table represents number of aircraft produced in the 5 months. If there was a mean of 325 civil aircraft, if there was a mean of 325 civil aircraft produced during that time, how many were produced in the month of B? A mean of 325 aircraft produced in these 5 months. How many were produced in the month of B? This problem is one of the easiest problems that we can think of for you guys, but don't try solving it. Just somebody should tell me the story from the question that there you have a table which represents number of aircraft produced every month, and the mean of the aircraft produced in this period of 5 months is 325. How many aircraft were produced in the month of B? Don't try solving it, just tell me the approach. If anybody wants to explain that to me, like how you would explain that to a 5th grader, please do so. Yes, Riya, go ahead.
So you would set up an equation with, like for the months you do A plus B, or A plus X plus C plus D plus E divided by 5 equals 325.
Oh.
And then you would solve it like that. And you would add it all up and divide it by 5 and get what X was.
Right. Everybody thinks the same way? Chris, Dhanvin, Dhanushri. I know some of you might be smiling behind the screen. Hey Gautam.
Hello.
So Gautam, you were missed in the last class where we talked about mean median mode. So basically the unit that we have started, that is called center, spread and distribution of data and data representation or data analytics. So we talked about mean median mode and then we talked about standard deviation. So a question to you, Gautam, would be, are you clear about what is mean median mode?
Yes.
Okay, then I'm not going there. Are you aware of what is standard deviation?
I don't know. I'm past.
Okay, then since we have less number of kids in the class, I want to use this opportunity for giving a different role to you guys. Can somebody try explaining, Gautam, what exactly is meant by standard deviation and what is the purpose of it? Just give that storyline and then I will do the calculation part of it. Anybody? And don't be shy. Trust me, the day when you start teaching a concept that you know, you will become better with that concept. Let's see who wants to give it a shot. Dhanvin? Yep.
Tell the answer?
I'm sorry?
For the answer?
Not for the answer. So Gautam was not in the last class and he knows what is mean median mode, but he doesn't know what is standard deviation. So if you give a quick 2-minute summary of what is your understanding of standard deviation to Gautam, just explain him conceptually and then I will do rest of the calculation part. But can you try giving it a shot?
Right, so first you're supposed to find the mean of the numbers there are, and then once you find the mean, you're supposed to subtract them with the actual numbers to find out the difference between both the numbers, the space, and then that divided by the numbers, like 5 in this case, would be the standard deviation.
Okay, that is the mathematical part, which I have a feeling that Gautam will learn and then he will forget. Anybody else who wants to give a little more insightful view of what exactly is standard deviation and how does it help? Riya, how about you, Vita?
I mean, I don't really know what the purpose is, but like I kind of forgot what the purpose was, but I know how to do it.
Okay. So Gautam, now you have to rely on my story. Okay. So when you know what is mean median mode, correct?
Yeah.
If I give you Okay, so this problem everybody knows, so I'm not going here. So this problem, this was one of the sample problems that I picked up from your study material, where we had the month by month production of civil aircraft, and one of the data was missing, and we were given the mean. So we were asked to find this one. So like the way Ria explained, or Dhanmin was kind of trying to explain, was that this is 5 months data and this one is not known, but you are given the mean. So as you guys know, if you have some data given, mean is nothing but the average of that. So you have this plus this plus this plus this plus this divided by 5. That's what will be the mean, because you're talking about 5 records. So 400 plus x plus 286 plus 350 plus 290. This whole thing divided by 5 would be a mean, and that value is given here. So it's like a simple equation where you will add the numbers, that sum of all these numbers plus x by 5 is this much. So from that you can find out the x. So that is a simple part. It was a word problem where the teacher could not do a great job to make it complicated. So this problem was also very simple. So now coming back to the standard deviation part, one more time I'll explain this, because mean, median and mode you guys will not forget. Standard deviation, there could be a little deviation at times. So now let's look at I'm just giving you guys a simple example. Okay. I have two sets of data. This is my set A and this is my set B. If I talk about mean of this, how much will be that, Gautam? Just give me 10 seconds without calculating it.
It'll be 30.
30, yeah, because you see that this is all uniformly distributed, and you see that there are 5 records, so you will just look at the central part of it, that will be 30. As you can see, that it's increasing by 10. Even if you add them together, divide by 5, it will be 30, getting 30.
Yeah.
Same way, if you are talking about median, you end up organizing them in ascending or descending order. It's already in ascending order, so you look at the middle number, and that will be a median as well. Correct?
Yeah.
Mode is a number that occurs multiple times in a given set. So that way, mode tells you that okay, which number has maximum occurrence in the data set that you are looking at. Correct? Now, why do we need to talk about standard deviation? What is a standard deviation actually? Standard deviation is a technique that tells you how much of data variance you are looking at among your different data elements. So if you look at this set versus this set, here you are seeing that every data is kind of if you put them in ascending order, every number is increasing by 10. Here, when you are putting them in ascending order, you see that everything is increasing by 1. So between two consecutive numbers, you know that okay, here the difference is 1, here the difference is 10. But then that is probably not sufficient. You might have a situation like now what do? There is no uniformity among the data that you are seeing. Here the difference between the first two elements, even if you put them in ascending order, first and second the difference is 2, second and third the difference is 3, again the difference is 2, and then the difference is 11. So there is no trend, there is no predictability that you can derive from this one. So standard deviation was used as a tool to say or find out how much is the fluctuation among the data elements in the given set that you are looking at. Okay, so let's do some calculation real quick, and then we will try to derive some interpretation from that. And I want everybody to pay attention to this, because this is what I want you guys to also get used to. Don't remember the concept that we are learning as a stressful exercise to memorize something. learn it like a story that remains with you. So that's why I was asking you guys to tell a story to Gautam. That okay, what is standard deviation? The story that I was expecting from you guys to come was standard deviation is nothing but a technique which tells you or helps you derive in a more mathematical way that how much is the fluctuation among the data elements that you are dealing with in a given set of records that you are analyzing or looking at. Okay. Now let's look at this. Let's say I have 1, 2, 3, 5, 6. Okay. Okay. Let me not complicate this for you. Okay. So let's say I have a set of data. Let's say I have only 4 elements. I want to rush through this calculation quickly so that we can save some time. I have these 4 data elements. Okay. I'm looking at a data set. I have 4 records. Let it be how many chapatis you ate for 4 consecutive days. On one day you ate 1, second day you ate 2, third day you ate 3, fourth day you ate 5. Now, mommy is trying to figure out on the 5th day how many chapati Gautam or Dhanushri or Biren would eat. Okay. I'm not saying whose data it is. It could be my data. It could be one of yours. Okay. Now, standard deviation is a tool that gives you one formula for calculating the standard deviation, and the standard deviation is equal to square root of sum of x minus mean square by n. Here this represents the sum. Okay, this represents the sum. What does it mean? Every element minus the mean square of that. So sum of the difference of squares of every number against the mean divided by the number of data elements you're talking about and square root of that. So don't try to memorize this formula. Okay, you will start hating me as a teacher. Don't do that. So forget about this formula. Okay, I was just trying to write that in a very intelligent way, which is not the case with me though. So here I have 4 records. First of all, we have to find out the mean. Okay, what is the mean here? 1 plus 2 plus 3 plus 5. 1 plus 2, 3, 3 plus 3, 6 plus 5, 11. 11 divided by 4. 4 3s are 8, 3.75. This is the mean I got. This part is okay, right? Nothing cryptic about it. Everybody knows. Now, standard deviation says take this mean and now do your calculation. So, pick the first element minus the mean square. I should have done something little different. 5, 3, plus 2, 11. Let me. Yeah.
I don't think 11 over 4 is 3.75.
2.75 it is. Yeah, it is 2.75. And anyway, that is one problem I'm trying to knock off. I don't want to get lost in the calculation of it. Okay, so I want to round it to natural number. So I made this 5 as 6. Now I have 1 plus 2 plus 3 plus 6. So 3 plus 3 6 plus 6 12. 12 by 4 gives me a 3. Yeah. So now I have a mean of 3. And on purpose I made it a whole number so that my calculation doesn't go for a toss. I mean, I don't end up spending a lot of time doing the calculation alone. So what this guy says is, I have the mean. Now I have to pick every number, compare this against the mean and do a square of that. So 1 minus 3 square plus 2 minus 3 square plus 3 minus 3 square plus 6 minus 3 square. What I did, I picked up every number and subtracted the mean from that and did a square of that. divided by the number of elements you have, 1, 2, 3, 4, and overall square root. So now let's quickly look at it. 1 minus 3 is minus 2, minus 2 square is 4, minus 2 square is 4, so I'm just writing 4, plus 2 minus 3 is minus 1 square is again 1, 3 minus 3 0 square 0, 6 minus 3 square 9, divided by 4, 4 plus 1 5 plus 9, 14 by 4, 14 by 4. Now Dhanvin will say, my teacher will go wrong again. 4 3 are 12, 2, 3.5. This time okay, Dhanvin?
Yeah.
Yeah, okay. Yeah. So, anyways, so I got 3.5. Square root of 4 gives me a 2. This is a little less than that. So let me just make it up. I'm just saying maybe it's 1.7. I got 1.7 as my standard deviation. Okay. So Gautam, here so far I have not told you anything interesting. Okay. This is a very boring calculation that I was showing you. But I was telling you how do you derive the standard deviation. And that is not convincing enough. So just hold your horses for a little bit. Just spend your energy and time to consume how this is done. First thing I did was I took the numbers, found the mean, and then subtracted the mean from every number that I had in my data set and did the square of the difference. Okay. And then after doing the square of the difference, adding them together and dividing that by the number of data elements I have in the set. And from that I got 1.7. Okay. This part is okay, Gautam?
Yeah, I understand.
Okay. So this is, there is nothing to understand in this one. This is only to let you know that okay, this is how you calculate. Okay. So far there is no meaningful outcome that you have got from this. Okay. You just know how to calculate. Chris, Dhanushree, Dhanvin, Riya, nobody has any doubt, right? I know you guys already know about it, but I'm just checking.
Yeah.
Yeah, okay. Now, Gautam, I'm playing with you now. I just tweak this one. I'm saying 3, 2 plus 1, 3 plus 3, 6. I have this record now. Okay? Or okay, let me make it a little more interesting for you guys. So here in this case the mean was 4. Okay? So what I will do is I will put 3, 2, 3 and 4. Okay? In this case, how much is the mean? 4 plus 3, 7 plus 2, 9 plus 3, 12 divided by 4. So, my bad again. This guy, this set has a mean of 3. This set has a mean of 3 as well. Correct? You will agree?
Yes, sir.
Now, but it's optically you can say that this set of record and this set of record is different. Correct? This set of record is different from this set of record. But your mean is coming to be same. Even if you try finding out the median, let's see what happens. 1, 2, 3, 6. Here it is 2, 3, 3, 4. Okay? Now here what will be a median? If you arrange them in increasing order and this set, here the median would be average of these two, which will be 2.5. Here the median would be 3. Pretty close, not very far. So your mean is same, your median is also somewhat closer. Just because we are looking at a smaller group of data, we are still seeing a difference. Imagine if you are dealing with 10 or 20 records, you might not see this difference. Okay? So these two group of records that we are seeing right now, that seems to be a little misleading. Okay? But we know for sure that there is a difference. How do I describe the difference? Any thoughts? How do we describe this difference without going to standard deviation part? How do you describe the difference? Anybody? And don't think too much of math, okay? It's common sense. between this set of records 1, 2, 3 and 6 and 3, 2, 3, 4, what is the difference that you see here? Nobody?
I have one difference, but it's not really related.
Go ahead and tell me.
First one, the range is 5, the second one, the range is 2.
Yeah, that's a good observation. Even if I don't know about the range part of it, I'm still seeing that here my numbers are changing. I mean, like you said, right? My numbers are changing much more here compared to this guy, correct? Which pretty much relates to what you said, Gautam, right? Now, but there's no mathematical way of saying it, okay? You can say, okay, my range is different. But again, we are talking about a small group of data. How about a record with 20, data set with 20 or 40 records, or maybe 60 records? What will happen in that case? You might not be able to see that range also. So let's come back to the actual intent that I'm trying to convey here. Now, in this case, I found a standard deviation of 1.7. Let's see what will be my standard deviation in this case. My standard deviation would be here. The square root of, again, 4 numbers. First number minus the mean. 3 minus 3 square. Plus second number minus the mean. Square. Plus third number minus the mean. Square. Plus fourth number minus the mean. Square. This became 3 minus 3 is 0. 0 plus 2 minus 3 is minus 1. Minus 1 square is 1. Plus 3 minus 3 again 0. 0. 4 minus 3 is 1. 1 square is 1 by 4. What did you get here? 2 by 4 or 1 by 2 square root, which is 0.5 square root, which could be maybe somewhere around 0.7. Okay. So now, if I erase everything here, what you see in this case, your standard deviation is 0.7. Okay. Now I'm giving you a third situation. Same 4 records. Okay. What is my mean for this set? 3. Median will be 3, same as other 2 sets, close to that. But standard deviation would be first record minus mean square plus 0 square plus 0 square plus 0 square by 4. What is that we get here? 0 by 4 square root. 0 by 4 square root, that is square root of 0, that is 0. Yes, somebody was saying something. Okay, now what is the meaning that is coming out of this? Now if you look at this 3 situation, here we got standard deviation is 0. Look at this situation, your standard deviation of 1.7, because the difference between the numbers was much more. Here the standard deviation got reduced to 0.7 because you saw that, okay, you are not fluctuating that much compared to the first set. Here you are not fluctuating at all. There is no deviation, there is no difference among the numbers that you have. This came as 0. So, to summarize, my last 15 minutes blabber in one line is standard deviation is a scientific tool that tells you how much of variance you are seeing with your data. Okay? Among the data set that you are dealing with. And again, all these probably would not make much sense when you are dealing with small set of data. There is a lot of things that you can interpret by just looking at it. Imagine a situation when a data scientist is dealing with 1 million records with numbers ranging in all possible directions, all possible values, and then he or she has to find out or derive the overall trend from the data and get some meaningful outcome from that. This becomes one of the tools. Does it make sense, Gautam?
Yes, I understand.
If I ask everybody in this class to tell a story next time, do you guys think that you are better prepared to give that story?
Yeah.
Riya, Dhanvin, Dhanushri, Chris?
Yes, sir.
Yep. I would want you guys to get into the habit of telling stories. Telling stories is not the level of blabbering I do, but more like, giving a conceptual view. What exactly is standard deviation? It's a tool. It's a technique used by a mathematician to look at your data and find out some insightful trend from that. Now, these three sets of data, if I look at it with my naked eyes, I would probably think they are pretty much similar, okay? Or I can say, okay, yeah, there is some difference here, there is some difference here, this one has no difference. But my response would not be very mathematical, not be very scientific. If I say that yes, there are three different sets of records where the fluctuation or the deviation among data is less here, your standard deviation is 1.7, here it is 0.7 and it is 0, that would be spot on, point blank, for anybody who is wanting a mathematical response to this question. Yep, everybody with me? Alright, so I wasted everybody's time. But you know what? Math is never a waste of time. Math is something that you enjoy and you need to enjoy. That's the only way you will actually fall for the subject. So, now moving on. So, we learned about some basic tools or techniques. Now comes the data representation part of it. And again, the same question that will come to your mind, that we have learned a lot of calculation, we know a lot of maths. Still this old man is bothering us to give extra gyan on something, may not be interesting. And that is not the case. I mean, I being the old man is not the case, is not true. That is true. But there is a reason for why we are learning these tools and techniques. If you guys have ever bothered to look at some of the websites or some of the reports that flashes on Google, remember the COVID days, I'm sure you guys were much younger during that time and you would have probably not bothered much about it. But for me, every day when I used to wake up during the COVID days, when there was a fear that whether we all will be alive next day or not, right? So there was a data that was coming for every country, every city. I mean, it's called Worldometer or something. I don't remember the name of the site now. It's been almost 5 years. So where it will say, okay, you can put a filter based on country and say, okay, fine. Day by day, how many new cases identified? How many cases cured? How many cases are still open or active? Similarly, for different countries, for different continents, there were different ways of slicing and dicing of data that you could do by applying filter on this one. And if you go to the root of that, it is as simple as somebody collects the raw data. It's like, today what is the temperature? In McKinney it's something, Frisco is something, Irving is something, Chicago is something else, New York something else. Every day data, somebody is feeding in the raw data. Let's say if I have 5 people or 3 people capturing temperature data for 1 month for different cities. Let's say city 1 is Dallas, next one is New York, next is Chicago. And day 1, day 2, day 3, day 4, day 5, day 6, and so on and so forth. Okay, day 1, 45 degrees. New York, 38 degrees. Chicago, let's say 47 degrees. And somebody goes on collecting the data. So 30 days, 90 days, whatever it is. Whatever is the task. Now if you look at this data is sufficient. This data has information, but this is not intuitive. This is not readable. Imagine I cluttering the whole whiteboard with so much of data, some junk, gibberish, whatever way I'm writing it, okay? There's so much information. But if you have to read all the information by yourself in a regular manual human way, it will be possible to read, but would that make any sense? Look at this data versus I picking up the same data and saying, okay, fine. This is day 1. Or I'll say, okay, fine. This is Dallas. And I put that with 30 bars. Let's say if I'm talking about 30 days data, I'm putting 30 bars here, and every bar representing the okay, let me not make it cluttered. Let me keep it simple to begin with. Okay? Let's learn anything first. Let's say I'm talking about only 1 day's temperature, okay? Or 2 days temperature, okay? Let me add 1 more day at least. So there is a way to compare. And so I have 3 cities, Dallas, New York and Chicago. Day 1, 2 and 3 temperature listed here. And you can visualize, imagine, extrapolate, say okay fine, how about 10 days record, 20 days record, and you can just assume that how voluminous this information would become and how difficult it will keep on getting if you have to look at this data in this table form. This is called unorganized data, unorganized information. What we are trying to do is, do we really want everybody to look at this kind of a table? What if tomorrow I have 50 cities, 2 more countries? Life gets more interesting. Compared to this, if I have something which is more visually appealing, let's say if I'm putting Dallas first, this is 48, 45, then 49, and then 63. Oops, 63 will be somewhere taller than this. This is my Dallas temperature. This is New York, 38, 36, and 32. Then I have Chicago, 47, 48, and 46. So this is Dallas, New York, and Chicago. If you look at these 3 blocks of information here on the board, you'll say, okay, fine. Just I look at the Dallas records, I can see the temperature has been increasing. When I look at New York record, it's decreasing, and Chicago is fluctuating. So just by looking at this graph, without struggling too much to read between the lines, you can make some meaningful interpretation from this data. Then okay, Dallas is increasing. That's why your teacher is sweating right now. Temperature is increasing. Last 3 days record. New York's temperature is decreasing, so you don't really have to pack your woolen clothes yet. Keep them out. You would need them. Chicago is okay, somewhere moderate, not very cold, not very hot, and it is still unpredictable. So just by looking at this information, the amount of interpretation that you can make versus looking at this raw data, there's a difference. And that is the purpose of this whole topic called data representation, and that's a big deal. With this information, if you go back to look at some of the reports, even some of you who are following IPL, go to a table, points table, or a lot of statistics are thrown for people to follow. People who are watching Super Bowl here, you'll find a lot of statistics around that. And those statistical details are provided in a more intuitive way using different charts and graphs that you see. And we'll go into detail of all of those charts and graphs one by one and try to understand what is the difference between them. But this is the foundation stone which is just to make us believe that why do we even need that data representation skill or ability to look at it. It's not just an extra burden on you guys as a student. It is enabling you to look at the information in a more constructive way. Once you guys grow up to become big shot in the organizations wherever you work, you would probably not have enough time to look at all this raw data as is. You would rather look for things which is concise, point blank, and gives you the ability to make quick decisions, which will impact hundreds of people. So that is the main purpose of the data representation, where it gives people the different level of views with the right intent and obviously the right content as well to make meaningful decision out of it, and then make meaningful interpretation out of it, and then correspondingly followed by the decisions. Is that making sense? Okay.
Yes.
Gautam probably got tired of my non-stop speech. Let me take a step back. So now hereafter, for next 1 or 2 classes, we will spend some energy and time talking about all those tools and techniques. Hey Gautam, are you able to hear me okay?
Yeah, it just disconnected me.
Okay. So I was thinking that probably you got tired of my boring speech. So basically, summary is all these tools and techniques that we will use for data representation, they have only one intent. That is how to ingest the raw data, unstructured data, unorganized data, and then use that data to plot something more intuitive, much more readable, and much more interpretable from an end user's perspective. Okay. Now, there are different tools and techniques that we'll come across, and those are bar charts. Bar charts or graph, whatever you call it. Line chart, pie chart. Then you have something called histogram. Then you have scatter plots. And again, every tool or technique that we talk about, there will be some very important and interesting details hidden underneath. So just not saying that, okay, I know bar chart. Probably there could be many more interesting facts which are hidden underneath. Okay, so we have to decode and unearth those to have a much more interesting view of these tools. Now let me go one by one. Let's see how good is your storytelling ability. Who all knows about bar chart and bar chart or bar graphs? And explain me what does it do with some examples. Yes, Ria.
But like examples of like what?
I'm sorry?
Like how do I get examples? Like
When you can just tell me a story, right? I mean, it's all about storytelling.
yeah.
So you can tell me what is the situation when you use bar chart, wherever you have seen.
So bar charts are good for like comparing situations.
Mm-hmm.
So you wanted to see like I don't know how many apples versus oranges you had. You could create a bar chart to see, okay, I have 15 apples and I have 10 oranges.
Okay. That's one situation. Okay. Let's see. Then if what is Dhanvin's point of view? Yes, Dhanvin. Dhanvin or Chris, Dhanusri. Yeah, Dhanusri, go ahead.
one example could be like comparing things over time. Like it could be the revenue or like what the cost that or the money that the company has gotten over the years, and it could be the many years, and it basically there shows like a growth or like loss, I guess.
Yeah, okay. That's another good example. Any other example? And you guys have to keep on thinking in a very simplistic way, okay? Think of some simple options, simple scenarios also. Anybody else? Dhanvin, Chris, Gautam? And I'm making an assumption that everybody has come across bar graph. So, or bar chart. Okay, let me give, so like you guys said, right? Riya and Dhanushri and Chris has not spoken. Okay, so Riya and Dhanushri. So whatever you guys said, that makes complete sense, where you use bar chart for repainting some comparison or repainting some trend over time. When I was born, I was this tiny. When I was 1 year old, I grew this big. When I was 2 year old, I grew bigger. When I was 5 year old, I became this big. After 16 years, I stopped growing. Can I put that in a bar graph? Yes, I can. So, bar chart or graph or line chart do pretty much the same thing. Let's look at them. So today we'll talk about bar chart, line graph and histogram. These three things we'll cover today. And then I'll let you guys go. And I'm saying that we'll cover today, we still have just 10 more minutes left, and that's the time we need because these are the concepts that you guys already know. So look at like a coordinate plane where along the x-axis, let's say I'm plotting time. 1 year, 0, 1, 2, 3, 4, 5. This along this axis I'm talking about years. Along this axis, let's say if I'm talking about revenue, like what Dhanushri was saying. I'll say when let's say somebody started a business in the first year, this is let's say $100 per month, this is $500 per month, this is 1,000, this is 2,000. When somebody started a new business, in the first year, he or she was making only $20 per month. Second year, maybe he was making $300 per month. Third year, he is making $1,500 a month. Fourth year, 6,000. Fifth year, 10,000. Now, just by looking at this bar graph, you don't need to rely on any story. Like people say, right? A picture says 1,000 words or says 1,000 words. This is that picture. Just by looking at this one, you can say, okay, fine. Oh, this is wonderful. This is wonderful. This is. If I just plot this thing here without having any intelligence, just with common sense, with just a glimpse of this picture, I can see, yeah, this is talking about the business. Okay, so I just need to have the context. Okay, this is talking about business growth of somebody or some company, some organization, some individual. First year was not investment, less earning. Second year, started showing some positivity, started becoming more significant, became more stable. So this is one example. Same way you can say, okay, I will plot the height of the people, how the kids are growing. 2 feet, 3 feet, 4 feet, 5 feet, 6 feet. I wish I could get here. Unfortunately, that's not the case, but it's okay. It's a last battle. So coming back to this one, I just have to find. We could see how the revenue changed or increased or how it fluctuated. Like for child, we have to find. After 1 year, the child was, let's say, 1 foot tall. After 2 years, he or she was 2 feet 5 inches tall. After 3 years, became 3 feet. 4 years, 3 feet 2 inches. 5 years, 4 feet. So this gives you a trend. So you can net you can see how your information is changing over time, be it in terms of revenue, in terms of growth, in terms of height, in terms of you can say, okay, fine. It could be like how many hours you study and how much marks you get. That also you can plot. Okay, if I'm studying 1 hour every day, I'm getting 30%. If I'm putting 2 hours of effort every day, I'm getting 50%. If I'm putting 3 hours of effort, again, I'm not counting study as number of hours. I'm just saying, if you're plotting it that way. So this gives you a trend where you're getting an outcome against one parameter. When one parameter is changing, what is the corresponding increase in that? So likewise, you can say, okay, fine. You can use a bar chart like this even for plotting how the COVID cases fluctuated across different days of a month. Yeah, Gautam?
Sorry, you went on mute.
No worries. So this is a situation where you can use a bar graph. And to your point here, we can use bar graph for a combined bar graph for also representing, let's say if I say along 5 years, let's say you planted one apple tree and one orange tree, both. Year 1, let's say this is red one is apple. And the blue ones are orange, meaning here I'm trying to plot how many hundreds of apples you got after you planted the apple tree. First year you got this many. Second year you got how many apples, how many oranges. Third year you got. So basically you can use the bar graphs for representing a trend or for representing comparison. When you talk about comparison, you will have 2 bars together, or you will have single bars throughout where you are comparing each bar against the other bar, or you will have a combination of 2 bars or 3 bars depending on how many data points that you are trying to compare over the period of time. Make sense? Priya, Dhanushree, Dhanvin, Gautam, everybody?
Yes, sir.
Okay. So bar graph is, in short, I can say, or we can say, that bar graphs are the tools that helps you to derive a trend or represent a trend or do a comparison of different data elements. Okay. Now, on the similar lines, if I talk about, let's say same scenario, okay, growth of child or let's say growth of revenue. $100, $200, $400, $600, again $300. Let's say if I'm talking about in 5 months, how much money, how much profit a store made. These are the months, 3, 4, 5 months. And this is 100, 200, 400, 300, and this is 600. I know if the store makes this much money, they'll go bankrupt and they'll close the store soon. But I'm just plotting the data. Here we have represented a trend or represented data elements over the period of time. We can do that like using a bar graph, or you can say I will not use bar, that makes it look very cluttered. I will instead just find these points. Like the way we find coordinates, right, in the coordinate plane. And I will join these points. If you look at this, first year $100, second year $20, $200 per month, third year $40 per month, fourth year $600 per month, fifth year there was a dip. So instead of making the clumsy looking bar graph, we use the same information for plotting it, and we just connected them as the way we will connect the points in the coordinate plane. That is called line graph. You are connecting the points using line. It does pretty much the same thing. Line graph you usually use for deriving a trend, where bar graph is more for trend and comparison both. Now if you look at it, you will say that okay, we can use line graph also for the comparison, and that's fair. You might have two line graphs for two different set of data. This is blue one for somebody who is as bad as me when it comes to doing business, and then the red one is for somebody who is better than me. See, this one also plots that line, but just by looking at this, you can see that okay, the data that is represented by the red line, or for the second business owner, is actually doing a much better job. Every month, by every end of every year, he has done better. And see, this guy had a dip also in the fifth year. Maybe he could not run the business successfully in the fifth year, but see, this guy became more consistent. So line graphs also you can use for deriving trends or comparison. In general, you will see line graphs are used mostly for trend, but it doesn't limit us from using that for comparison either. And it helps you derive the trend in a much more neater and cleaner way compared to the bar graph. Bar graphs will look little clumsy, little cluttered. And imagine if you're talking about bundle of 3 sets of data that you are plotting against time, imagine how cluttered it would be. Extrapolate that to think of 5 sets of data that you are trying to plot, how clumsy it would become. Compared to that, if you have, let's say, 5 lines, this is still readable and intuitive. But as far as the ability or capability of these tools are concerned, line graphs and bar graphs can be used interchangeably depending on how you want to beautify your report, how you want to kind of plot it, which one you are more comfortable with. But both have similar capabilities, if I can say so. Does it make sense?
Yes.
Okay. So we'll probably stop here, okay? So bar graph and line graph. I know we got a little deviated because we wanted to touch upon the standard deviation part also, because Gautam was not there in the last class. And since we don't have the other kids as well, so good that we are not covering a lot of things today. Otherwise, I will end up repeating the same thing for you guys, and you guys will probably get little more bored, because if you cover a lot, I'll be repeating a lot. So it's a blessing in disguise. But did we all follow whatever we discussed today?
Yes.
So my only request to you guys would be, whenever you learn anything, don't learn it as a subject. Learn it as something that you will use. And always ask that question to yourself, that okay, if I'm learning this, where exactly do I see the practical application of that? If you get the answer for that, either by yourself or by asking somebody, trust me, you'll be more convinced, more excited to learn those concepts. Yeah. So with that being said, I'll let you guys go. I know it's time for dinner, and you guys have school today, tomorrow as well. Yeah.
Yep.
All right. Enjoy the rest of the evening. See you guys on Saturday.
Bye.
All right.
Sir, do you know when the makeup class for the pre-calculus will be?
Pre-calculus, probably we might not do makeup for pre-calculus because I was thinking that pre-calculus we have only 2-3 of you, right? So we'll try going with the same pace, and then we'll try covering as much as we can. More with respect to the polar coordinates that we learned in the previous class. We will finish that one, and then we'll continue with that rest of the things, Chris.
Okay, thank you.
Yep. All right. Thanks everybody. Thanks, Manushree.
Thanks, sir.